related to C++ tutorials. Today we're going to talk about uh, finding out the peak and the minimum peak uh, within a two-dimensional array in C++. So we will be talking about integer arrays and for the sake of simplicity, what I'm going to do is I'm going to declare uh, uh, an array which is an 8 by 8 array just for the sake of visual representation. Once you declare 8 by 8 array, what I'm going to do next is I'm going to populate it with random numbers generated by variable seed random number generator. So it's not pseudo random numbers, it's random numbers. And so if you look at this red box, this is the area that I'm going to search in, and I'm going to leave out the outer rows and columns in the interest of simpler code. So what peak essentially means is when a value, so let's look at this number 99, if all of its neighbors are smaller than this value, then we say that this is a peak. And clearly this is a local peak, not the global peak of this entire array. A global peak would mean the largest value inside the array, which might as well be the same number because I don't see a number greater than 99 here. Nevertheless, we are working with local peaks and local minimum peaks. So if this value is larger than all of its 8 neighbors, then this is the local peak. And as you can see here, if this value is smaller than all of its 8 neighbors, then this is a minimum peak. Now, so we start at this green box, we finish at this point. So we are actually starting at location 1, 1 and finishing at location 6, 6. Okay, so in our first iteration, what we have is essentially this is your current value. We define this as the current value, and then we write another set of nested for loops inside this set of nested for loops that take care of my visiting each element in the addressable area. And when I run this internal for loop, which is represented by this blue box, I only run for 3 by 3 matrix. So my internal for loop, nested for loops, run for 3 by 3 matrix each time. So first I start with 6, match it with 8, 6, 5, 21 itself, 15, 64, 65, and 31. And if I find that all of these 8 matches are smaller than 6, then this is a peak and I note this value. Otherwise, I see if this is smaller than all of its 8 neighbors, then this is a minimum peak and I save that value as well. If it's neither, then I just move on to my next element, which is 15 in this case. So this is what my array looks like, and if I just draw it, you can see the output of my code. The output essentially is just recording all the peaks and minimum peaks. So I have a peak at 0, 4, I have a peak at 1, 1, 1, 6, 1, 8. So right now, for this output, I've actually enlarged the area of my red box. So I'm basically looking at all of these, but the code that I'm going to show you first is going to be just the inward to make it simpler. So let's start writing this. And so what we have here is my regular includes. I'm going to seed the random number with the current time. So I need time, I need standard library, and so first of all, I'm going to declare 2 constant integers, constant int rows, which is a value 10, for instance, constant int columns. This is pretty regular stuff, which is a value 10 as well. So my first function that I'm going to write is init array. Okay, this is a void function, and this function takes in an integer array of with 10 columns, or columns. Now note that I don't provide the value of the rows because C++ compiler simply ignores it. Even if you provide this value, all you have to provide is the columns. Right here, I would like to just define this function now. So init array, and this function essentially is a simple for loop, set of for loops that populate the array with random numbers. So say ARR, again rows, you don't have to define rows, just columns, and so I'm going to use a function srand or srandom and give it a seed value of the current time each time it's used. This is a pretty standard features. You can find this solution in the literature as well. Again, this is not the purpose of this video. The purpose of this video is to essentially write the code for finding minimums and maximums. So our regular nested for loop situation here. And in here simply ARR I and j is equal to just random. So this just populates my array. Next up, I'm going to write another function which basically prints my array, and I'm going to say print array, and it's an integer array again with this many columns. I'm going to just define that function here, void print array integer ARR. Now the name in this function can be any name. I'm sure you know that much. And so then the next one then is to print this array. Now printing is, again, I'm going to reuse this. I'm going to copy paste the same set of for loops and these for loops inside here. I'm going to say cout and ARR I and j, and then I'm going to give it then I'm going to do a tab, and outside the inner for loop and inside the outer for loop, because so right here outside the inner for loop and inside the outer for loop I'm going to print the next line. So in line, this moves my code to the this moves the output to the next line. Next up, I'm going to write the actual function that finds peaks. So void find peak. Again, this function takes in an integer array, and this function is going to find the peak value inside the two-dimensional array. And now you need to pay attention here, because what I'm going to do is I'm going to define a set of nested for loops. So not a set of for loops, a set of nested for loops. So int ARR columns, and so first off I'm going to store the value of my current variable, in a variable called current. So this is going to store this value 6 right here that you see on the right hand side. Next up, I'm going to declare a variable called peak counter. I'm going to initialize it to 0, and then a min peak counter, and I'm going to initialize that to 0 as well. Next up, my outer for loop. So this is basically the red for loop here. This red for loop starts from 6, ends at 8. So I'm going to write this outer for loop here. For int I starting at 0, I less than rows minus 1, because we're not going through all the rows, and I plus plus. Now, small mistake here, I'm not starting at 0, I'm starting at 1. Next up, the inner for loop, again, j equals to 1, j less than columns minus 1. I'm basically disregarding the last row and last column. Now, inside this for loop, I have to now write my logic for finding the maximas and minimas. So, first off, I assign the value of the current variable to the variable current. So, I and j. Now, this is going to hold 6 once again. And now I'm going to create another for loop, nested for loop, which takes care of my blue box here. Okay, so this blue box start at the index. If this index, which is for 6, is 1 1, then what is the value of this index? Is 0 0. So this outer for loop starts at 0 0, finishes at 2 2. So technically speaking, it starts at the current index minus 1 at rows and the current index minus 1 at the columns. Okay, and it goes from there to the current index, which is 1 plus 1, and current index at the columns plus 1. So it goes from 0 0 to 2 2, and that is exactly what I'm going to do. Because I want to generalize this, I don't want to hard code any index values. So the outer for loop, int k 0. Now we are starting this one at 0, less than you want to call it k, you may want to call it the inner matrix row, just for clarity, equals to 0 inner matrix row, or let me give it a smaller, so let me just call it k. K is equal to 0, k less than I plus 1 and k plus plus. So I'm not starting at 0, I'm actually starting at I minus 1. So I'm starting at I minus 1 at row and going up until I plus 1 each time. So this doesn't change. Inside I have int L equals to, again, I minus j minus 1, which is the rows, L less than j plus 1 and L plus plus. Now, interestingly, I cannot go to j plus plus, because then this will only run from 0 to 1, because this is 2 in this case. I want this is 2, so this will run from 0 and to 1, just 2 times. And what I want is for this to run for 3 times, so I'm just going to say greater than equal to at both of these locations. Now inside here is basically my logic. So essentially, if statements, I'm just creating a match. If ARR K and L is less than current, if my array is less than current value, which means if 8 is less than 6, then what should we do? If it's less than 6, this means current is larger. I want to increment the peak counter here. And notice that my peak counter, when the value of the peak counter is 8, that is when I've found a local maxima. And the value, when the value of my minimum peak counter is 8, I find a local minima. Okay, next up, if ARR, K, and L is greater than current, then I want to increase the min peak counter. And that's essentially it. That's all the logic that you need to find local maximas and minimas. Now, what we need to do next is, once we're done with these set of for loops, we go out and we say whether we have found the local maxima and minima or not, or if we have, where is it. So each time this blue box is done, I know if I've found the local maxima or local minima, or peak or minimum peak. So I know right after this blue box. And this blue box is this inner set of for loops right here. So I go ahead and I say if peak counter is equal to 8, if peak counter is 8, then see out peak at, and this is kind of a, so just printing the indexes, printing a comma, again, the other index j, the closing bracket, and moving on to the next line. And I'm going to just copy this as well for the other one. If min peak counter equals to 8, then print this, min peak at a particular location. And as you would imagine, once you do this, and as soon as you're outside of this inner set of for loops body, you want to reset your counters. And we do that right here. So we say peak counter equals to 0, min peak counter equals to 0. So let me just go through this once again. I start at the, I basically go through the inner box, and 6 is my starting value. In this particular example, I match it with all of its 8 neighbors, this one, this one, this one, and all of these neighbors. And if 6 is the largest among all of these neighbors, which is not the case here, then I just skip it. If it's largest, then I print or store that value. So outer for loop is my red block here. The inner for loop, set of nested inner for loops, is my blue block here. I'm going to also show on the next slide the output, so that should help you. But remember to call all your functions, and before you call your functions, you have to create that array. So an integer array rows times columns, because we're going to declare it in our function. We don't really need to initialize it. right with the declaration. So init array, and inside goes my array as an argument. Next up, I'm going to print my array, again, my array as an argument, and finally find peak and my array as an argument. So that's it. You have your functions. These are just the prototypes. Your print array function, your initialization function, your print array function, and this actually is your find peak function. Thank you very much for watching. I hope this video helped you, and watch out for more videos on C++ tutorials.